Hello, my name is Alex Paniagua, and this is my group's ENGI1331 Project 2. We had the circuit analysis. So our job with this code was to use Kirchhoff's laws to analyze a circuit and calculate their currents with given resistors and to find the limits of voltage. So our first step with this code was to create a function called circuit solver, and here it is. This function takes in 5 values, 2 voltages, and 3 resistances, and then outputs 3 values of currents. And we find the 3 values. I3 we find by taking the sum of V1 times R2 and R1 times V2 and dividing this by the sum of R3 times R1 plus R2 and R1 times R2. Kind of complicated, I know. We find I2 in a somewhat simpler fashion by just taking the difference between V2 and the multiplication I3 and R3 and dividing this by R2, and then we find I1 by doing V1 minus I3 times R3 and dividing this by R1. Now let's get to our actual project code. We start with our normal housekeeping commands, and we first load in the values given in the VR function that we were provided by the professor, and here it is. Our voltage values and our resistance values that we will be using for this code. Now as I said, we load in the values and then we use our circuit solver function with these values to get our 3 currents. And then as you can see, these 2 matrices right here are empty. We will be using them later on in tasks 2 and 3. And this counter as well we'll be using in our for loops. Now first we create a cell array with the initial values, and we use this because we're going to output all the values in our task 1, because task 1 is to create an array, a 3x3 array, showing voltage in the first column, resistance in the second column, and the calculated currents in the third column. And we use the cell array and our fprintf statements shown here to neatly display this information in our command window in a 3x3 matrix. Now task 2, in task 2, our job was to find the maximum and minimum limits for voltages, making sure, and we do this by making sure that the current stays in between 0 and 1. Now, we use this for loop using V2, and we use values from 0 to 100 in increments of 0.1, and we substitute these values into our circuit solver equation to get different values of I1, I2, and I3. Now what we do is we make sure that all these values are in between the limits 0 and 1. It cannot equal 0, but it can equal 1. And if all 3 values satisfy this, then we save it into a matrix, a vector known as V2 set, as you can see here. Now the way we find the maximum and minimums is that the last number saved into the V2 set will be our maximum, and we save it into this variable here. And the first number in our vector V2 set is going to be the minimum saved in this variable here. And then lastly, all we do is simply fprintf to show the minimum and maximum voltages. Now task 3 was to test how the value of the resistance in R3 affects the allowable range of the voltage of V2. We do this first by creating 2 for loops, one for R3 using values from 15 and 115 in increments of 1, and another for loop for values of V2 going from 0 to 120 in increments of 0.1. And again, we use our circuit solver function, substituting in these values, R3 and V2, to get our new currents. And like we did in task 2, we have this if statement to make sure that the values of I1, I2, and I3 are in between the limits 0 and 1. And if it satisfies this, we save it into a vector known as V2 range. After this, we take the maximum and minimums of V2 range, same way we did in task 2. The last value of V2 range is going to be the max, and the first value is going to be the minimum. We also save the averages, the average of V2 values, into the function V2 average by using the mean function we have in MATLAB. And as you can see, this is only for one value of R3 and one value of V2. And so what we do is we erase the vector we have in V2 range and start this loop over to get our new maximum, our new minimums, and our new averages. And we do this for every value from 0 to 120 in increments of 0.1 and 15 to 115. From here, we fprintf the minimum voltages, the maximum voltages, and the average voltages for every resistance from 15 to 115. And we use for loops to neatly display this in the command window. And then lastly, we plot all this on a graph using the values from 15 to 115 on the x-axis, which is the resistance, and then the maximum values and minimum values on the y for voltages. And the title of this graph is minimum and maximum voltages versus resistance. And then lastly, we will answer the given questions in our command window using these fprintf statements below. Now let's see how this code works. As you can see, the given values in VR are voltages 1, 12, voltage 2, 9, resistance 1, 100, resistance 2, 120, and resistance 3, 65. So now, if I just run this code, as you can see, we get our graph, but we'll look at this later. Let's look at the command window. Our task 1 was to create a 3x3 matrix showing our values of current, resistance, and voltage. And there it is. Our task 2 was to see the current effects on voltage. And we get that for the minimum for the current to stay between 0 and 1 amp, the minimum voltage allowable is 4.8 and the maximum is 34.1. And lastly, for task 3, we get every single resistance from 15 all the way to 115, as you can see. And along with this data, we are given the minimum voltage allowable, the maximum voltage allowable, and the average voltage. And we use these values, we use the resistance, minimum, and maximum to plot this on the figure, as you can see here. The blue line shows the maximum voltage, and the red line shows the minimum voltage. And then lastly, we answer our two questions here. The relationship between voltage and resistance is that the maximum voltage exponentially decays as resistance increases, while the minimum linearly increases. And to optimize the voltage range for the circuit, the resistance in R3 should be kept as low as possible because as resistance rises, voltage range decreases. And that's how you optimize it. The graph one more time. And that is our code. Thank you.